In 2014, Dr. Jeff Donnelly from Woods Hole Oceanographic Institution and a group of graduate students flew to the Bahamas with the goal of taking sediment cores from blue holes and sinkholes to reconstruct an ancient hurricane record. Upon arrival, they got held up in customs and much of their equipment was detained. That didn't stop them. They constructed a coring platform using a borrowed raft and other locally sourced odds and ends to continue their mission. For Richard Sullivan, this was the first of what would become many trips to the Bahamas to take sediment cores.
It's a target-rich environment. You look at the map and there's blue holes and sinkholes all across the islands in the offshore region. So we just had a long list of ones we wanted to investigate, and Great Cistern Sinkhole was one of the ones on the list.
This mission was a success in numerous ways. Not only did they find evidence of past hurricanes, they also found evidence of life. A human bone. A really old human bone. I'm meteorologist Emily Gracie, and you're listening to Off the Radar, a production of the National Weather Desk. On the show, we dig deep into topics about weather, climate, the ocean, space, and much more. Our goal is to help you better understand the weather and to love it as much as we do. Today's episode is the second in a two-part series about blue holes. Last week, we heard from Jeff Donnelly, the lead researcher of the group. He spoke about tracking ancient hurricanes using sediment cores from blue holes. And he also shared an interesting discovery from that first trip to the Bahamas in 2014.
So a human bone was recovered in this sinkhole on Abaco in the Bahamas. And we radiocarbon dated it. And it's pre-Columbian. It dates to about 1300 AD.
Today, I'm digging deeper into this topic. I'll be talking with Richard Sullivan. He was one of Jeff's research assistants at the time. He has since continued to study paleoclimatology and is now doing postdoctoral work at Old Dominion University, working both in the Bahamas along with the Yucatan Peninsula in Mexico. He'll share all the details from that day that they found the bone on Great Abaco Island and how they used carbon dating to help better understand when the native Lucayans settled in the northern Bahamas. And because of this information, they were able to basically rewrite North American history. First of all, a lot of people don't know what blue holes are. Can you give me a quick recap, and we talked to Jeff about this a little, of what a blue hole is?
Yeah, blue holes are these very specific type of coastal or marine environments where you have a very significant change in depth over a very short area, basically falling off the edge of the earth, right? There are these, they exist in very specific types of geologic environments in which the subsurface geology has dissolved in a way that leaves this like chimney structure that is the perfect environment to collect the sorts of material that then washes it over time. And they can be significantly deep, right? The deepest blue hole I've ever visited is Dean's Blue Hole at the Bahamas, which is one of the deepest blue holes in the world. You can walk up to it. It's like 30 centimeters right off the beach, and then it just is 600 meters straight down to nothing. It's really unnerving swimming across it.
Yeah, I bet. Is there folklore surrounding blue holes? There's got to be like old folklore of like this transports you to a different portal.
Absolutely. I mean, they've occupied a lot of different places, different spaces in different mythologies and religions. But like even when you're swimming across one today, you just have this feeling like some sort of ancient mystical beast is going to come out from the bottom.
Do sharks like go down there and circle around?
We have seen sharks in them, right? It all depends how connected they are to the ocean. Some of them are very well connected through subsurface passageways, and some aren't as well connected. But yeah, like Dean's Blue Hole, for example, you'll swing over and you'll see very large fish down below because they can get in and out, right? But some of the other ones that we've been to, they're closed off from the ocean, so there's not much going on in there. But yeah, I mean, to get back to your earlier question, like the ancient Maya, they had blue holes occupied a place in their belief system, right? They were ways to connect the underworld, right? And in the Bahamas, the blue hole represented an opportunity for burial sites, right, among the indigenous Lucayans, which is partly why we believe that bone was there that we found.
All right, so let's talk about that. Can you give me a recap of this bone and how it was found?
So in 2014, we had our first real expedition to the Bahamas to sample to collect sediment cores from the numerous blue holes in that environment. And it's a target-rich environment. You look at the map and there's blue holes and sinkholes all across the islands in the offshore region. So we just had a long list of ones we wanted to investigate, and Great Cistern sinkhole was just one of the ones on the list. And it's a terrestrial site, so it's not offshore, it's onshore, but separated from the coast by about 10 or 20 meters or so. So we showed up there with our rafts and our sediment cores, expecting that we'd sink the tube down to the mud, pull it out, split it open, and then see those transitions between the fine-grained mud and the coarse sand that we then infer as evidence of past hurricane variability. So we show up, we sink our sediment cores, get them back to the lab, split them open, and sure enough, there's textural variability there, but there's also this large chunk of bone just sitting right about 30 centimeters down from the top of the core, or that particular core. And we'd never found anything like that before. And we were like, at first we were Googling, like, is this a human bone? Is this an animal bone? Well, it's definitely human. And then it's like, do we call someone? There's someone looking for this person. But, based on what we knew about the site, we realized very quickly that it was quite old, that it was likely dated to, pre-European contact.
Yeah, what's your knowledge of bones like? Did you know that it was a leg, or did you have to do some research on that?
We had to do some research on that. My background is in archaeology, but not in osteology. Like, I'm not an expert on bones at all. Again, at first we were like, is it a cow bone? But there are cows. There really are cows in the Bahamas. So we had to do some research to figure out that, it was in fact a human bone. And we spoke to some other experts who were able to identify it conclusively as the upper part of a tibia dating to an adolescent individual, right? And they were able to figure out that based on just some of the way it was shaped and the way it had broken off from the rest of the tibia. That as you get older, I guess the tibia fuses more, so it's less likely for these parts to become separated. But when you're young, it's a lot easier for the upper part, which is called the epiphysis, to separate, which is what happened in this case.
So a teenager, male or female, can you tell?
Not from the tibia. If we had, pelvic bones or some other bones, then potentially, but no, not just from the tibia.
Could you, from looking at the bone, tell what this person ate?
So that's a good question. And it's partly yes, right? So trying to figure out the age of these things, we applied a couple of different techniques. We dated the bone directly using radiocarbon dating. And then we also were able to date leaf matter that we found above and below the bone. And that's one of the advantages of the way we operate, is that we get these continuous sediment cores that keep everything stratigraphically intact, right? So we not only had the bone, but we then had the material below it and directly above it. And when we dated the plant matter, we were like, okay, this thing is about 700, 800 years old. But then when we dated the bone directly, it gave us a much older age. And at first, we were like, well, that's kind of irritating. We were hoping for an easy answer here. But then we remembered that radiocarbon dating is dependent on the individual's diet, right? That, the carbon that we intake that is then dated during in radiocarbon analysis depends on where that food comes from. Terrestrial plant matter and marine organisms will give you very different ages based on the way carbon cycles through the atmosphere and through the ocean. So an individual who eats a largely marine diet will give you a radiocarbon age that is older than what it actually should be. Okay,
so then, do you know how old this bone is?
Yeah, so it is to about 1340 CE, right? But it was a little bit of detective work to figure out, okay, what contribution, of the marine diet versus the terrestrial, plants in the Bahamas were, flucaians eat. And some previous work had been done to sort of suss that out. And we figured that, okay, taking what we know about the contributions from the marine versus the terrestrial elements of the diet, and then what we know about the dating from the leaf matter above and below, we were able to say that it looks like this person got, I think 67% or 2/3 of their diet came from marine resources and 1/3 came from terrestrial resources. And that gave us an age that locked us right into the middle of our other age constraints.
Okay, so take me in history here in the Bahamas, and what can you tell me about? I mean, we know about Columbus and North America and kind of that American history. What can you tell me about Bahamian history and the indigenous people of the Bahamas from this time period?
So I will admit that I am no expert in the Bahamian archaeology or Bahamian history, but we do know that human migration into the Caribbean began around 5000 BCE with most likely from, American Indians coming from like the Yucatan crossing over to Cuba. Right. And that seems to be the first evidence we have of human migration into the Caribbean. After that, it seems like populations from South America started to migrate up from the Lesser Antilles and the Greater Antilles into Puerto Rican, the Puerto Rico and Cuba again. But the shift from those islands to the Bahamas seemed to happen a lot later. It wasn't until about like 700 CE or 80 where we start seeing evidence of humans in the southern Bahamian Islands. But even then, it was a really slow progression from those islands north. And the northern Bahamian Islands, which is where we found the bone, were some of the last islands to be colonized. And we're not, up until recently, we weren't entirely certain when that actually happened, right? And this bone gives us more evidence that they were colonized by this time period. And subsequent analysis has sort of shifted that back to about 800 to 900 CE based on sort of circumstantial evidence. We start seeing that we don't have any bones that date older than 1200, but local, faunal populations like tortoises that were foodstuffs for the locals, they went extinct around 800 CE. So it's like humans showed up, animals went extinct, they became more common, humans became more common there, and then we start seeing evidence of them directly.
So is this the oldest bone found in Great Abaco? Oldest human bone found in Great Abaco?
Nope, there was a previous bone found at Sawmill Sink just a little down the road from Great Sister, and that dates to about 150 years before that, right? But one of the interesting things that we realized is that bone had been incorrectly dated, right? And through no fault of the researchers who did the work at the time, but as we do more analyses in the areas, we start to fine tune these calibrations that we apply to our radiocarbon dates, so by taking what we know and then applying it to that bone that had been found previously, we were able to then also give a more concrete date for the timing of that burial as well.
So after this time period, then what happened in the Bahamas?
So then that's about 1300 CE or so, and then as we know, at around 1400, 1500 is when Europeans showed up, and things changed substantially. Right, the northern Bahamian Islands never seemed to be quite as densely populated as the islands to the south, and then once the Europeans showed up, the entire archipelago was largely depopulated from the native Lucayans. And that's part of the importance of the sort of work that we're doing, that, the Lucayans did not have an oral, did not have a written tradition. They didn't record their history written down. They had an oral tradition of, just communicating with each other. But once the Europeans showed up, that was lost. All right, the Lucayans are a functionally extinct people. So now we have no direct account of who they were and what they did prior to European colonization. So when we find these sites, it's like really important for us to, get things right. When were they there? Who was this person, right? There's a lot of things we don't know, but everything we can figure out, of course, helps to, clarify their story.
They ate turtles. I guess you know that much. They ate all the turtles.
Yeah, exactly. Yeah, ate turtles. We also see evidence of increased burning. Humans show up in an area. We have campfires, we have forest fires, we have to clear land. So that is another one of those pieces of indirect evidence that we see in the region. That in our sediment cores, people who look at these sorts of things will find increased abundance of charcoal, from ash from fires that humans have lit in the area. And that's another common indicator of human presence. That we eat things and we burn.
The Lucayans, that's their name. It's not a very long time period. So are you going to continue to search for other evidence of this time period and bones? Are you continuing to search sinkholes and blue holes for these bones?
Most of my work has been in paleoclimate reconstructions, focused on reconstructing hurricane activity across the Caribbean. Most of my recent work has been focused in the Yucatan Peninsula, but also in reconstructing periods of increased drought and rainfall across the Caribbean writ large. So in addition to the bone that we found in Great Cistern, what we were also able to infer from the sedimentological evidence there was that the islands had experienced intervals of prolonged drought versus increased rainfall that lasted for centuries. And that over the past 8,000 years, we'd had intervals of just several hundred years of increased rainfall, followed by several hundred years of significantly decreased rainfall. And that likely played a role in how people were migrating throughout the Caribbean.
So that's why Great Abaco sat empty for a while, was because of drought?
It's entirely possible, right? So and that's work that is continuing by our group, right? That we collect more sediment cores and more sinkholes to really iron out the details of when those droughts occurred over the past several thousand years.
Wow. Can any of the research you're doing tell us anything about our climate of the future?
I mean, that's a large motivation for what we do, right? is that in order to understand what's going to happen in the future, we have to be able to better contextualize what we see around us and understand the variability that's happening before, right? So we, develop these long-term climate reconstructions, be they drought or hurricane or some other variable. And then we can use those to sort of put constraints on what we would expect to happen under certain conditions, right? In fact, the work I'm doing here at ODU is using climate models to sort of fill in the gaps in some of our paleo reconstructions. Right? So, we have these very discrete reconstructions of hurricanes from the Yucatan, drought from the Bahamas, hurricanes in New England. Well, there are blue holes everywhere. So we have to use climate models to then figure out what was happening between those points. And then, take a step backwards and go, okay, what's the larger climate system doing that's driving these specific changes that we're seeing? And then that can help us figure out what changes we can expect in the future.
This is very cool. Very, very cool what you do. So in the bone was a surprise, but it helped, right? It helped understand that time period. Have there been any other surprises that you have found that have been helpful in that way?
So, one of the things that was really interesting about that site is that in addition to the human bone, we also found a crocodile skull dating to about 2,000 years ago, which belonged to a now extinct species of crocodile that was once common in the area. And then at the very bottom of that core was the skeleton of a Bahamian boa, which is a large snake that is still common on the island today. And it was wrapped around a charred piece of wood, right? So we were like, why would a snake end up in a sinkhole? But then we're like, well, it's wrapped around a charred piece of wood. There's a bunch of trees overhanging the site because it's on land rather than offshore. And we inferred that what probably happened is that you had a snake in a tree and then lightning or something caused a forest fire and that tree fell into the hole as it burned, taking the snake. It's an unfortunate way for him to go, but it gives us these high resolution sort of snapshots of time, right?
That's really cool. Any other random things pop up in these sediment cores?
So nothing specific is interesting as again, as human bone, but again, it's what these cores can tell us. So my work in the Yucatan has focused on reconstructing tropical cyclone activity, in the Western Caribbean over the past several thousand years. When one of the motivating questions is how have local populations and indigenous cultures sort of reacted in regards to changing climate conditions? Can we infer anything, or at the very least, can we sort of provide the constraints of what the climate system was doing, and then link that to the archaeological evidence of what was happening culturally and socially? So a lot of work has shown that the decline of the Maya civilization coincided with periods of increased drought across the region. Right? But one of the remaining questions is, what about tropical cyclone activity? So what we showed with the core declare from the Yucatan is that the decline of the Maya civilization occurred during a period of increased tropical cyclone activity in that part of the world. Right? We're not saying that it was hurricanes that pushed the Maya off the edge, but it's just one more piece of, what's one more environmental stressor, right? That you're dealing with drought, you're dealing with famine related to drought, and then all of a sudden you got a couple more hurricanes every year, right? That sort of combined stresses will, push a civilization to the brink of collapse potentially. And that's highly relevant today as we start, seeing all these things compounding on top of us, between sea level rise, storms are getting stronger, increased drought or swings between drought and then flooding.
Yeah, absolutely. Wow. Any other cool research you're working on that you want to share about?
I think everything I do is kind of cool,
Yeah.
but it is all very down in the weeds of understanding these very complex, climate interactions.
Are you going on all of these missions? Are you physically doing this yourself too?
Yeah. When I started working for Jeff back in 2010, he hired me basically to, run all of his field campaigns. So I was the one going off to, the Bahamas 20 times over the course of several years. It was in Alaska. We did a lot of work in Alaska. And, we did work in Africa for various reasons. So it's really exciting, going to these places and then interacting with the locals directly, which is a really cool part of this work, right? When you go to a place like the Bahamas as a tourist, you tend to engage with the tourist side of things. But one of my favorite places in the Bahamas is South Andros Island, which is one of the least touristy islands in the entire archipelago. Everyone who's there, they're fishing communities, right? And they all have stories to tell about the storms that they've seen and what they think is happening, how the land has changed from sea level rise. And it's really cool to get those sort of perspectives. But yeah, we're going to be going back to the Bahamas, I think, this fall. Ultimately, I would like to keep doing work in the Yucatan. Because, like you get every individual core is just a very specific slice of what's happening at one point in time in one location. And more information is always better to fill in these gaps.
Where in the Bahamas are you going in the fall?
We're going to be going back to Sub Andros Island. It's very close to Great Abaco. It is the largest island in the Bahamian archipelago, and it is just south of Grand Bahama and just west of Abaco.
Gotcha. Okay. Yeah. I've spent a lot of time in Great Abaco. We fly into Marsh Harbor, and we went to a blue hole, and I was like, I'm not getting in there. But he did like the cannonball in there. I was like, no, you're never coming back. So that kicked off my interest, but I'm still not getting in one.
Well, I mean, it is unnerving, right? Like you're swimming across. Yeah. What if the laws of physics all of a sudden give way and I just sink straight down?
Right. And it's also like we couldn't see. Like I could not see at all down into it. So that was unnerving.
Have you been back to Abaco since Hurricane Dorian hit?
Yeah, it's crazy flying into Marsh Harbor, like just all, the distraction, all the trees. So yeah, we drive south for like 20 minutes and all of a sudden, like slowly the trees start getting their tops back.
No, I mean, I've not been to Abaco since Dorian hit, and it looks devastating. I remember the last time I was in Bahama, you see all the pine trees there are basically matchsticks just waiting for a storm to come along.
Yeah. Right.
Yeah. I mean, it's such a low-lying place, and that is like sea levels drop, storms get more intense. It's, an increasingly vulnerable location. But that is one of the things that our work is, that all these analyses show is that the Bahamas and the Yucatan, they're the kind of locations in the Caribbean that see the most number of storm strikes, right? And it looks like there are periods in the past when the Bahamas was actually struck more common than it was today. So which indicates that it could get worse.
Is there, if you go back there and start looking in blue holes, are you going to find evidence of Dorian already? Like, is recent history in those sediments?
Yeah, that is a key part of what we try to do is, we call it like a modern analog, right? So, when we collect our sediment cores, we're looking for transitions between, sand and mud as indicative of, storm overwash. A storm comes along and mixes up all the sand and coarse grained particles and then drops it into the hole, right? And then the storm recedes and you get fine grained mud again, and then you get the sand again, right? But after a storm like Dorian, we would expect to see that, right? So we go to sort of, verify our hypothesis that this is what happens when a storm comes through, is that you see this very thick layer of sand at the top is related to Dorian. And we often deploy like sensors around the islands in these holes to sort of measure things like currents. And when Hurricane Irma hits in 2017, what we see in our offshore current sensors is all the water on Little Papa off the coast of Long Island got completely washed away from the island, right? So you have a current sensor there measuring, water flow, and then it just goes flat as all the water was gone as the wind just pushed it all offshore. And then it comes right up when the water comes back. So it's a pretty dynamic place. And monitoring the current climate is a key part of this.
Are you going to go back to that same blue hole? Because that's, Dorian's eye sat right there. That blue hole is right near Marsh Harbor, right?
Yeah, I think that's part of what we're planning to doing this fall is going back. Well, it's going to be Andros as opposed to Marsh Harbor, but try to go to these sites and see what happened after Dorian. But I would love to go back to Sister and see if there was any evidence of storms. If any evidence of Dorian was archived by that hole. Like I said, there's a lot of different moving pieces in what we do, right? Everything from human bones to changing human migration patterns and the collapses of civilizations. It's a lot that you can learn from mud and hole in the ground.
I hope you're as fascinated by this story and by paleoclimatology as I was. It's incredible how they can explore how climatological conditions may have influenced the trajectory of past indigenous communities no longer around to tell their story, like the Lucayans in the Bahamas. Richard is headed back to the Bahamas this fall to continue the research. Off the Radar is a production of the National Weather Desk. Make sure you're following the show on Apple Podcasts, Spotify, or wherever you listen to podcasts. New episodes publish every Tuesday. If you have a weather nerd in your life or someone that's interested in blue holes or paleoclimatology, please share this episode with them. We'd also love you to rate and review us on Apple Podcasts and Spotify. Also, check out our YouTube channel. Just search the National Weather Desk. You'll see beautiful images of blue holes. This podcast is produced, hosted, and edited by me. Special thanks to Ryan Berlin for his help. I'm meteorologist Emily Gracie. Make it a great day.